I'm going to talk about the history and future of scientific paradigm shifts. We need a paradigm shift in the way we approach environmental management. A paradigm is a set of beliefs that defines the ways in which we think and act, and a shift in paradigms is a real shift in worldviews. And this concept was promoted by Thomas Kuhn and Karl Popper. Kuhn wrote a groundbreaking book, The Structure of Scientific Revolutions. Now, in order to gaze in the crystal ball to look ahead, the best way to start is to look backward, and that was Winston Churchill's famous quote. So let's start in 1543 when a Polish astronomer, Nicholas Copernicus, took the existing paradigm that the Earth was the center of the solar system and created a new paradigm, and that was that the sun was the center of the solar system. And this was because society really wanted to understand where in the solar system the Earth and Sun were related to one another. He published this on his deathbed, so it was really up to his successors, including Galileo Galilei, the Italian astronomer, who debunked the existing paradigm that the heavenly bodies consisted of an ethereal substance and came up with a new paradigm that heavenly bodies consist of physical matter. And these are wonderful drawings of the phases of the moon that Galileo himself drew using his invention, the telescope, which opened up astronomy to many more people. And another astronomer, a German, Johann Kepler, looked very closely using Galileo's telescope and was able to describe that the elliptical orbits of the planets, debunking the paradigm that the planets were in a perfect concentric circle around the sun. That, with a lot of other physics, went on to describe the motion of various heavenly bodies. In the late 1600s, Isaac Newton, a British physicist, studied the laws of physical matter and the existing paradigm that the forces of natures were unique, and replaced it with a new paradigm, and that was that there were these universal physical laws of nature. And we still use his three laws of thermodynamics, for example. And then in the early part of the 1700s, a Swedish biologist, Carl Linnaeus, began to look through the plants and animals that the various explorers, including himself in his Lapland costume here, were collecting from the far reaches of the world and bringing back to Europe. And he took the multiple names of organisms and came up with a systematic approach and a uniform method of naming, which we still use. And then in the early part of the later part of that century, the chemist, a French chemist, Antoine Lavoisier, debunked the existing paradigm that phlogiston, some magical compound, was causing candles to burn, and came up with a conservation of matter, that matter was neither created nor destroyed, but just changed form, and of course showed oxygen and the other components of the atmosphere. Then in the early 19th century, the geologist Charles Lyell, in trying to understand the formation of Earth, debunked the catastrophe theory promoted by the Bible and the 6,000-year-old age of the Earth, and replaced it with a paradigm that the Earth was much, much older, and that the uniformitarianism, the processes in the past, were the same as today. So erosion that you'd see in the fossil record was related to erosion in currently. And his famous student at the Charles Darwin, who came up with a theory of natural selection, debunking the creation paradigm. And in these drawings of finches they did on the Galapagos on this famous 5-year voyage of the Beagle really rocked the world. This was a bestseller, the Origin of Species, and he really changed the way we all think. And then the early part of the 20th century, a physicist, Albert Einstein, took the paradigm that energy and mass were immutable, replaced it with the most famous equation, E equals mc squared, that energy and mass are interchangeable. Note, he was Time Magazine's Man of the Century because of the theory of relativity that really changed fundamentally the way we view the world. And then in the latter part of the 20th century, the biological revolution, ushered in by the description of the structure of DNA, and replacing the paradigm that chromosome proteins were the basis of inheritance. So a British scientist, Francis Crick, and an American postdoc, James Watson, at Cambridge University, published this in the journal Nature in 1953. Rosalind Franklin provided the X-ray crystallography to support that. Well, finally, the reason we're looking backward is to look forward and coming up with a sustainability revolution. And this revolution, that the existing paradigm is that we have irreversible environmental degradation, and the new paradigm that the environmental solutions are possible. And so this is really what we need to focus on, is the societal need to figure out how we're going to live on this finite planet with 8 billion people. And these paradigm shifts occur when the society is informed about these scientific discoveries. So these revolutions are revolutions in the way we think, based on earlier the societal need to understand where we are in the universe, where we come from, and what we're composed of, and now sustainability, how we can survive on this planet. Then finally, this history of science can be conveyed or described in more detail in a couple of papers and books. The paper that I'll put onto the file share, and then this book, Charles Murray, which describes the human accomplishments in the last millennium.